So we're going to let's look at a few more exercises with law of sines. Exercise 1 should have felt pretty straightforward. Exercise 2, you probably want to watch that video a couple times. That was a little bit more involved. Let's look at a few more situations here. Exercise 3, solve the triangle if alpha is 25 degrees, side A is 16 centimeters, side B is 10 centimeters. So we let's see, we have to find angles beta and gamma, and we have to find side C. And if I were to kind of draw a picture here of what's going on, let's see, put the 25-degree angle here maybe. Across from that angle is 16 centimeters. Call this beta. Across from that is 10 centimeters. Here's gamma. Side C, my hypothetical picture, I don't know if the triangle looks like that, but that's going to help me get started here. And let's bring out our law of sines to help us set things up. Let's see what I can say about this triangle. So sine of alpha, sine of 25 degrees over side A, 16, is equal to sine of beta over side B, which is 10, equals sine of gamma over side C. So again, I want to pick two of these to work with. I like sine of 25 degrees over 16, and I want to work with sine of beta over 10 because sine of gamma over C, I don't know gamma or C. I don't want to put two variables in the same equation. Okay, so let's try to solve here. So I'm going to plug in a value for sine of 25 degrees. On my calculator, I get 0.4226 over 16 equals sine of beta over 10. So that's an equation where I want to multiply both sides by 10 to isolate sine beta. I get 10 times 0.4226 over 16 equals sine of beta, because those 10's on the right will cancel. And let's figure this out on my calculator. Multiply 0.4226 times 10, divide by 16. I get 0.2641 is sine beta. And now to get an angle out of this, we're going to use the inverse sine, right? Use sine inverse. But now we saw last time sine inverse gives us one possible value for beta. We have to also consider 180 degrees minus the inverse sine value. The inverse sine angle. So that's the complication to use in law of sines. When you're trying to find an angle, the inverse sine will give you one. It will always give you an acute angle for a triangle less than 90 degrees. And we need to figure out what the other possible angle is that's greater than 90 degrees. So for inverse sine here on my calculator, again in degree mode, make sure you're in degree mode, I get 15.3 degrees. So that's a possible value for beta. So beta equals 15.3 degrees, or beta is equal to 180 minus 15.3 degrees, which is 164.7 degrees. So I got these two values of beta that I have to consider. So I'm going to write my answer. Now that was my answer in the previous video where I wrote triangle number 1, triangle number 2. And I'm starting to sum up my information. So alpha is 25 degrees, alpha is 25 degrees. A is 16 centimeters, B is 10 centimeters. That's true for both. And now I got my angle beta could be 15.3 degrees, or my angle beta could be 164.7 degrees. Okay. And now I got to figure out gamma as an angle and C as a side, right? And the gamma as an angle is the easier part to figure out, because if I add alpha plus beta, I'm going to just write this on the side, alpha plus beta plus gamma is 180. So I have 25 plus 15.3 plus gamma is 180 degrees. Keep that on the side. And I can figure out what gamma is from that, right? My gamma is 139.7 degrees. 139.7 degrees. And what about over here? In my other situation, alpha plus beta plus gamma is 180. I have 25 plus 164.7 plus gamma is 180. All right, wait a minute, what's going on here? 125 plus 164.7, that's 189.7 degrees. I'm in trouble. So I'm already over 180 degrees with just 2 of the angles. There's no way, gamma can't be negative, so there's no way I could add another angle and have a total of 180, because I'm already over 180. So what that means is this is impossible. So there's no way beta could be that other value, and we don't really find it out till this step where we're trying to figure out the third angle. Well, I guess if you realize that you have 2 angles that add up to more than 180, that's it. You throw that one out. So this triangle 2 is not a possibility. There's only one answer here, and we still need to finish that part up. We need C. Okay, so what we saw was we had to consider 2 possible beta angles, because you never know. The previous video gave us 2 possible answers. Here, when we started working on our 2 possible answers, we found out that one of them is impossible. So we throw it out. We only have one answer, and I still got to find side C. So I need to write sine of 139.7 degrees over C is equal to sine of 25 degrees. I'm using alpha over A is 16 centimeters. Sine of 139.7 is 0.6468 over C equals that sine of 25 degrees we already had, 0.4226 over 16. And so when I solve for C here, I get C is 24.5 centimeters when I solve 24.5 centimeters. So here, there's just one answer. There's my answer. This stuff all got thrown out. There's only one possible triangle. Let's just take a look at some cardboard cutouts here. Let's see if this will show up. I guess I gotta back out a little bit. So what I did was, again, I cut out some paper to try to reproduce the given information here that angle A was 25 degrees, that side A is 16, side B is 10 centimeters, and the side C is along the bottom, so we don't know how long that is. And I actually can move this A side to try to get different possible answers. Now, I have to land exactly on that base. I can't be short of it. I have to touch it, but I also can't cross over it because then that A side is not the full 16 centimeters, right? So there's a position that gives me a possible answer right there, and that's actually the answer we got for triangle number 1, right here. And what happened to triangle number 2? In the previous problem, we were able to swing this side along, and we got another answer. But notice here, side A is so long, as I swing around, I totally miss side C. I don't even touch it, because side C has to end here at the vertex of the 25-degree angle. So it's a similar situation to the previous exercise, but we're doing this swinging thing to look at our possibilities. But the problem is this 16 centimeter side is so long, we never get a second triangle out of it. There's only one possible position. Okay, now I'm hoping I can do the last exercise on this same video, because this one won't be as long, I hope. And so let's just set it up. Exercise 4. And solve the triangle if A is 25 degrees, alpha is 25 degrees, A is 5 centimeters, B is 15 centimeters. Now I'm actually going to go right to writing down sine alpha over A equals sine beta over B. That's the part of the law signs I'm going to make use of here. Sine of 25 degrees over 5 equals sine of beta over 15. And we got to solve for beta. So what I want to do is multiply both sides by, I guess I want my sine of 25 degrees, and I don't know what to do. Oh, the calculator fell on the floor. There we go. 25 sine is, we've been using that one over and over again. I should have used it from the previous problem. 0.4226 over 5 equals sine of beta over 15. So I'm going to multiply both sides by 15. And on the left, I get 15 times 0.4226. 15 times 0.4226 divided by 5. I get 1.2678 equals sine beta. Now we got a problem here, and I don't know if you have spotted it yet, but sine beta is always less than or equal to 1, always. Values of sine and cosine can never be larger than 1. So we can already see there's no solution here. Now, if you miss that, and say you keep on going, say you try to calculate sine inverse of 1.2678. 1.2678 sine inverse, I get an error message on my calculator. So my calculator knows there's no solution there because it's impossible. There's no way the value of sine can be greater than 1. So what's our conclusion here? We got to answer this, that there is no triangle that satisfies the given information. So we were set up with an impossible situation from the very start. And you know, you got to say that, or you got to say no solution in this kind of problem. You got to indicate that it's just impossible. And just to take a look at my pieces of paper one more time, if you made a little kind of paper cutout like this, you'd see right away how this is just ridiculous. Here's my 25-degree angle. Here's my B side, 15 centimeters. A is this little 5-centimeter side. There's no way by swinging that side around, it never comes down to where the C side is. There's no way to get a triangle out of this. And that's basically what the no solution for the sine beta is telling us, that there's no way to get a triangle out of this kind of situation. So there we are, no solution. And I think that's the end of our law of sine problems.